Hello students, we have studied Laplace transform, its properties and discussed some problems. I hope you have understood these problems. If you have any doubt, please do ask me. So now we are moving to the next topic, inverse Laplace transform. As we all know that every transform have their own inverse forms. So let us look into the general formula of the inverse Laplace transform. So here we can see that the inverse Laplace transform of f of s can be written as f of t equal to L of inverse, that can be used as inverse Laplace transform. Inverse Laplace transform of f of s. We studied that Laplace transform can be written as L of f of t equal to f of s. So in inverse Laplace transform, f of t can be written as inverse Laplace transform of f of s. And we study the important Laplace forms. So there is a formula for inverse Laplace transforms, and the formula is inverse Laplace transform of 1 by s equal to 1 by x equal to 1. And in case of Laplace transform, we can see that L of 1 equal to 1 by s. So in inverse Laplace transform, 1 by s equal to 1. And inverse Laplace transform of 1 by s minus a can be written as e raised to at. And inverse Laplace transform of 1 by s raised to n can be written as t raised to n minus 1 by n minus 1 factorial. And inverse Laplace transform of s by s squared plus a squared can be written as cos at. And inverse Laplace transform of 1 by s squared plus a squared can be written as 1 by a sin at. And inverse Laplace transform of s by s squared minus a squared can be written as cos h at. And last one is inverse Laplace transform of 1 by s squared minus a squared can be written as 1 by a hyperbolic function of sin at, that is sin h at. And these are the formulas for inverse Laplace transform. And the properties of inverse Laplace transform, we can already study the properties of the Laplace transform. So here the same properties of inverse Laplace transform. If inverse Laplace transform of f of s can be written as f of t. So in the case of shifting property, we can see that the inverse Laplace transform of f of s minus a equal to e raised to at f of t. An integral property, it can be written as inverse Laplace transform of integral s to infinity f of s ds equal to 1 by t f of t. In division property, inverse Laplace transform f of s by s equal to integral 0 to t f of t dt. And the last one is derivative property. Inverse Laplace transform of d by ds of f of s can be written as minus t into f of t. And these are the properties of inverse Laplace: shifting property, integral property, division property and derivative property if the inverse Laplace transform of f of s equal to f of t. And we are moving to problems. Find the inverse Laplace transform of 1 by s cube. We know that inverse Laplace transform of 1 by s raised to n can be written as t raised to n minus 1 by n minus 1 factorial. So comparing this equation, we get that here n equal to 3. So here n equal to 3, that is inverse Laplace transform 1 by s raised to 3 can be written as t raised to 3 minus 1 by 3 minus 1 factorial, that is t squared by 2 factorial. That is inverse Laplace transform of 1 by s3 can be written as t squared by 2 factorial. Then the one is find the inverse Laplace transform of s1 s plus 1 by s raised to 4, that can be split into two. Inverse Laplace transform s by s raised to 4 plus 1 by s raised to 4, and we cancel s, that is inverse Laplace transform of 1 by s3 plus 1 by s raised to 4. We already know the formula is inverse Laplace transform 1 by s raised to n can be written as t raised to n minus 1 by n minus 1 factorial. So 1 by s3 can be written as t raised to 3 minus 1 by 3 minus 1 factorial, and s raised to 4 can be written as t raised to 4 minus 1 by 4 minus 1 factorial. So we get t squared by 2 factorial plus t cube by 3 factorial, and we know that the 2 factorial is 2 and 3 factorial is 6. So it becomes t squared by 2 plus t cube by 6. That is inverse Laplace transform. S1 plus s plus 1 by s raised to 4 can be written as t squared by 2 plus t cube by 6. The another one. Find the inverse Laplace transform of s squared minus 3s minus 4 by s cube. So we can written as inverse Laplace transform s squared by s cube minus 3s by s cube minus 4 by s cube. And cutting s, we get that inverse Laplace transform 1 by s minus 3 by s squared minus 4 by s cube. So we know the formula is inverse Laplace transform 1 by s can be written as 1, and inverse Laplace transform 1 by s raised to n equal to t raised to n minus 1 by n minus 1 factorial. So the equation becomes 1 minus 3 into t squared 2 t raised to 2 minus 1 by 2 minus 1 factorial minus 4 into t raised to 3 minus 1 by 3 minus 1 factorial. That is 1 minus 3t minus 4t squared by 2. Cancelling 4 by 2, we get 2. That is 1 minus 3t minus 2t squared. And another one. Find the inverse Laplace transform of 3s plus 4 by s squared plus 9. That can be split into 2. That is inverse Laplace transform of 3s by s squared plus 9 plus inverse Laplace transform of 4 by s squared plus 9. That is 3 into inverse Laplace transform of s by s squared plus 9 plus 4 into inverse Laplace transform 1 by s squared plus 9. Using formula inverse Laplace transform s by s squared plus a squared, it can be written as cos at, and inverse Laplace transform 1 by s squared plus a squared equal to 1 by a sin at. So inverse Laplace transform s by s squared plus 9 can be written as cos 3t, and inverse Laplace transform of 1 by s squared plus 9 can be written as 1 by 3 sin 3t. So equation 1 becomes 3 cos 3t plus 4 by 3 sin 3t. And the last problem is find the inverse Laplace transform of 4s plus 15 by 16 s squared minus 25. That is inverse Laplace transform of 4s by 16 s squared minus 25 plus inverse Laplace transform of 15 by 16 s squared minus 25. That is can be written as inverse Laplace transform of 4s by 16 into s squared minus 25 by 16 plus inverse Laplace transform of 15 by 16 into s squared minus 25 by 16. By taking outside 4 by 16, that is 4 by 16 inverse Laplace transform s by s squared minus 25 by 16 plus 15 by 16 into inverse Laplace transform 1 by s squared minus 25 by 16. We know that we can return s squared by 25 by 16 can be written as s squared minus 5 by 4 whole squared. That is 4 by 16 inverse Laplace transform s by s squared minus 5 by 4 whole squared plus 15 by 16 inverse Laplace transform 1 by s squared minus 5 by 4 whole squared. So we know the formula that inverse Laplace transform s by s squared minus a squared equal to cos h at, and inverse Laplace transform of 1 by s squared minus a squared equal to 1 by a sin h at. That is inverse Laplace transform of s by s squared minus 5 by 4 whole squared can be written as cos h 5 by 4t, and inverse Laplace transform of 1 by s squared minus 5 by 4 whole squared can be written as 1 by 5 by 4 sin h 5 by 4t. And by simplifying last, we got that 1 by 4 cos h 5 by 4t plus 3 by 4 sin h 5 by 4t. Thank you.